Ladies and gentlemen, I'm really happy to be here in Bled again at this SAS Colloquium. It's such a nice atmosphere at this colloquium. I appreciate very, very much to be invited for such a long time already. I feel at home, I must say, in a certain way. I'm going to give a presentation about the consequence of neglected pavement maintenance. And first I want to acknowledge my co-author. You saw him directly now, Alfred Wenninger-Witsutil, and it's for me an opportunity also to thank him for a very, very good and excellent cooperation for many years already. Yesterday morning, we heard from the president of the IAPA that asphalt is not so sexy, at least for political view. So that means road construction also is not very sexy, maybe. But I can tell you about something which is even less sexy than road construction in the view of the politicians. This is road maintenance. And this is the reason for several studies we did in the last years to have good arguments to convince politicians to provide more or at least enough money for pavement maintenance. The first study, I think I had the opportunity also to, can we go to one picture only? It is on my, thank you. Some years ago, 2 years ago, for the state road administrations, for the road directors, as a basis for tolling plans. There were plans to make a tolling, to implement a tolling system, which is at the moment only on the motorway, perhaps on the state road network, at least for trucks. And to have a background about the needs of budget, this study was made, investigating the whole Austrian state road network. You can see this was the result, just to show that quickly. For the pavement, you see the actual budget and the actual need according to the results of this study. And this here is the additional need. So yeah, you can see for the pavements, we found that there is an additional need of about 64%. For the structures, more than 100%. So in total, for the total network, about 80% would be the additional budgetary need to fulfill these underlying conditions. We were calculating for a structural backlog of not more than 30% in the network. And I must also confess that for the structures, this was only a very, very rough estimation, because while for bridges there are really good figures, but for retaining walls, and we have many retaining walls in the state road network, there is almost no or very little information. Not only on the inventory, this is the first point, but of course then on the condition and the need of maintenance. So this was the first outcome, but and all of you know that, of course, there are always economic problems in the public sector. So the danger is that not only these additional funds are not available. This is a wish list. But on the other hand, it can be that some actions may be postponed or even forgotten at all, some maintenance actions. So the target of this additional study was to assess the effects of neglected constructive maintenance. In this time, we focused for the first stage on the pavement only. And the main question of this study was, what is the effect of do-nothing, of a do-nothing strategy over a given period on the later budget demand compared to the costs to keep the initial condition of the network on the same level. This was the strategy we used for this study, and it is interesting that the study was made for the Chamber of Employees in Austria, for the Department of Transportation Strategies or Transportation Politics. So also this side of the community is interested that there is a well-maintained transportation network. We used for this study, of course, it was mentioned recently, also the life cycle cost analysis to provide the necessary measures when a certain threshold limit is reached or we come close to this limit. We have a performance functions for these several condition elements in the pavement management system we use in Austria. And the condition of the road or of the pavement is expressed by two indices, by the Comfort and Safety Index, CSI, and the Structural Index. You can see it better on this next figure. Here you have the different performance indicators, skid resistance, rutting, and so on. They are linked together or brought together to these two sub-indices, Comfort and Safety Index and Structural Index on the other hand. And for the normal analysis, these two sub-indices are combined to a total condition index, and with this total condition index in the background, the analysis is made. But on the other hand, and I will come back to that later, these two sub-indices are also used to investigate certain targets. So, for instance, the Comfort and Safety Index is used to look at additional user costs, for instance, and the Structural Index, I will explain that in the next sheet, is used to evaluate the asset value. And this was, the asset value was the point we used for the comparison in this study. So we choose a representative road sub-network of the Austrian State Road Network for which all necessary data were available. The do-nothing period was taken for a maximum 10 years, while the analysis period, as always, is taken for 20 years. The do-nothing strategy was related only to the constructive maintenance. Routine maintenance is not in focus within this study. And this is very important. Each evaluation, each results I'm going to show are on network level. Of course, for the, during the analysis sections, several sections are estimated and evaluated, but the results are valid for the whole network in view. And it was necessary to define a reference maintenance scenario for the comparison with this do-nothing strategy for several years. So this reference scenario was defined as a strategy, a maintenance strategy, for which the distribution of the SI, the structural index values, within the net, and the asset value based on this structural index are kept constant on an initial state. So you can see that in this graph here. This is the distribution of the structural index values over the years, 20 years for the analysis period, and the scenario was chosen in such a way that this distribution is kept almost constant as far as possible compared to the initial state. And here you can see the same for the asset value. The asset value we are calculating in connection or in relation to the actual structural index. So the value of the structure is the basis to calculate the asset value. We don't make a linear depreciation over time, but it is connected to the structural index. So you can see in this reference scenario, the asset value is kept constant over this period. This was the procedure and the way we conducted the study, and the first result you can see here. You can see the relationship between the necessary additional investments and the duration of the do-nothing period. And you can see that already after a do-nothing period of, let me say, 5 years, you will have to invest up to 24 or 25% more compared to the budget you would need to keep this initial state. So you don't save something if you do nothing. In contrary, you need more money. And this is increasing rapidly the longer this do-nothing period will take. And then there was the idea to look what is the influence of the initial status of the network. If you have a poor or a better network, is there a difference? And for that reason, we divided the subnetwork, which was under investigation, into 2 subparts, again, with 2 different initial values for the structural index. And there you can see the results. This is the result. The red curve is for the total network, and this is the curve for the part of the network which is a structural index which is a little better than the total, and this is the other one where the condition is worse. And from this, a general formula was developed so that we can now either calculate it directly with this formula, but also you can see it here in this graph. If you know the initial status based on the structural index of a given network, you can assess the necessary additional investments after a given period of do-nothing. So in this way, this result, which was developed for an Austrian state road network, could be used for each other network as long as you have the necessary input values. This is the side of the road owner. This is necessary to show the road owner what additional investments are necessary if maintenance measures are postponed or neglected. Finally, in a very rough form, we were looking at the effects on user costs. We made a general estimation of the additional user costs due to the postponement for 2 reasons. Or the user cost caused by increased vehicle operating costs and increased travel time costs. This was just to show that also the users are, in a way, confronted with these problems. We used the basic assumption for the Austrian state road network, derived from different sources. Time cost rates, we considered the additional travel time costs only if the IRI was higher than 5 meters per kilometer. This is a very, very rough surface you will never have on a motorway, for instance, if I look at you, but maybe it is on state road state road, it can happen, or community road in any case. And we used the basic relationship coming from HDM4 just for this overall assumption. So the additional fuel costs, the additional operating costs in relation to the do-nothing period showed that there is a very big increase of these additional costs the longer the do-nothing period leads. I must confess this is a very rough and general estimation just to show that there is an effect on the users as well. And the same is now for the additional travel time costs. And you can see also that after 4 years, 4 or 5 years, there is a clear effect on the additional travel time due to the deterioration of the pavement after this longer period of do-nothing. So to come to the conclusion, the target of the study was to assess the effect of zero maintenance over a given period on the investments, which were later necessary then to receive the initial condition again. So the comparison was always made, I want to stress that again, to a given initial condition, not an improvement, to come back to the initial condition again. We used for this reference scenario I tried to explain, and we found that there is a clear relationship for the Austrian state road net between the duration of do-nothing and the later maintenance needs, ranging from 25% of additional funds after 5 years and 150 after 9 years, for instance. And furthermore, the influence of the various initial conditions situation was evaluated, and thus this is the result is also a general solution which is applicable for other networks. And finally, also additional user costs were estimated, ranging from approximately 2 million euro per year up to 28 million euro per year, depending on the do-nothing period. Especially these figures here, they are very drastic, I must confess. Of course, after 9 years, if you tell them they have to spend 150% of money more than they would have spent during the do-nothing period. But on the other hand, I feel that it is necessary that we show these figures in a very drastic way. This is the only possibility that the politicians can understand that. In the same way as you have these red roads on the map, this is understandable easily, and it is here similar. You must show that it is necessary to have enough money, and I'm happy, and yesterday evening some optimism came up, I think, to all the audience. I'm feeling that now also the political level finds that it is necessary to have a well-maintained road network, and the readability is increasing to provide the necessary funds. But it is still necessary to have good arguments, because we are always in competition with the other public sectors, and money is short in all the sectors. So I thank you very much for your attention, and again I say that I'm very happy that I had the opportunity to come to Bled again. Thank you.